Hey everyone, it's Mr. Flanagan here, ready for another day of math. This is the Unit 6, Section 3, Triangle Similarities notes. This will be the first piece of notes while I'm gone. So what we're going to be doing is I'll be going over the notes just like I do in class, where you're going to be able to go through each of the notes, make sure you follow along, pause the video if you're getting confused, and rewatch what you need. We'll go over everything like we need to, and then you can practice your homework using both the online tools as well as the physical paper. So the first thing we're going to do is talk about proving triangles similar. Recall that if two polygons are similar, polygons shapes, we know that their angles are congruent. So we're going to write congruent here on the space. Do this with me. Just for the future, if I write something down, I think you should as well. And all the sides are similar. Now you want to think to yourself, what's the difference between congruent and similar? Congruent means that they have the exact same, for angles, they have the exact same measurement. So if one angle is 60, the other one is also 60. If one is 80, the other one is also 80. The corresponding ones are the same, exactly. But similar doesn't necessarily mean the same. If I have one length that is 3 meters long, the other one might be 6 units long, or 6 meters long. Um, the idea is that they're going to have the exact same scale factor, and we're going to talk about that more as we go more into this. So the first thing we'll say is there are 3 ways to show that 2 triangles are similar, and here are your 3 ways. There's angle, angle, knowing that 2 of the angles are the same. Another is side, angle, side. And you might recognize this from when we did proofs of triangles. And side, side, side. These are the 3 ways to show that triangles are similar, not necessarily congruent, but similar. And the first one we'll talk about is angle, angle. And this was not from the triangles when we had to prove them similar. The angle-angle similarity postulate says that if 2 triangles have 2 pairs of congruent angles, like we see in these 2 pictures right here, then their angles are similar, or the triangles are similar. Determine if the following 2 triangles are similar, and if they are, we're going to find GE and MR, which are those missing sides right there. And we want to look at these triangles, talk to yourself. You're saying, okay, I have this triangle LGE and AMR, these 2 different triangles, and one's pretty obviously bigger than the other, just by looking at it too. Not only that, but also the numbers associated with them. What I like to do when I do these problems is kind of resituate these triangles in my head so that way they're facing the exact same direction. So I'm going to try to rewrite this triangle right here so it's in the exact same direction as AMR. So if I rewrote that triangle, and forgive my drawing, it's not fantastic, but I have this triangle that's now, these 2 triangles are kind of similar in shape as far as how it looks. So I know the double angle here and the single angle here, and the single one is G, the double is E, and the one that doesn't have one associated is L. I know LE is 32 from the picture before, and I know LG is 20 from the picture. So what you can tell, which is really cool, is that this side is associated with this side. And this side is associated with this side, but we don't know that number. And also, this side is associated with this side, but we don't know MR either. What we have to do is figure out if these are first similar, and if they are, how can we find those missing sides? First thing we can do is really easy, and it determines if it's similar or not. Well, we just talked about if you have an angle, if 2 angles in a triangle, they are automatically similar no matter what. These triangles are similar, so those are already guaranteed. What that means is all of the sides share a common scale factor. The idea behind that is if I divided 32 by 24, because those sides, those orange sides, are associated with each other, that'll give me my scale factor. I could also do 24 over 32. That'll be the same kind of thing. So 32 over 24, those are both divisible by the same number, which is 8. So if I divide them both by 8, I would get 4 over 3. And then if you wanted to put that in a decimal, 4 divided by 3 ends up being roughly 1.3. Repeating. Just so you could see what that really ends up being. So what I know is in order to get the bigger side of the triangle, so if I'm looking at, let's say, this one right here, this yellowish circle, what I have to do is I have to multiply the smaller number, this 21 right here, by my scale factor, this scale factor right here. And that way I can get that empty spot. So what I'm going to do is multiply 21 by 4 over 3. When I do that, that's 21 times 4, and then divided by 3. And that ends up being, let's see, 7, so you get 7. 7 times 4 is 28. I'll just check my math real quick. Times 28. Sorry, times 21. And it's 28, yeah. So 28 is this missing side right here, EG. So we know EG is equal to 28. Or GE, the same thing. Now we're going to do the red one. But this time, you don't have the smaller side. We have the bigger side already. So we're not going to multiply by 4/3. We're going to multiply it by the reciprocal 3/4. So we want to multiply by the reciprocal of the scale factor. That way it goes from big to small. Because 3/4 is less than 1. So when you multiply something that's less than 1, between 0 and 1, it's going to become a smaller number. So we're multiplying 20 by 3/4. So 20 divided by 4 is 5. So 5 times 15, or 5 times 3 is 15. 15 equals that MR. So MR equals 15. So these are the two things we were looking for, EG and MR. And you can go back and do that again. Just go watch the video if you're feeling confused. The big thing is finding the scale factor and then using it to translate this 21 into EG and translate this 20 into MR. All right, now we're on the side angle side similar theorem. This is the idea that if you have a side that is similar, and then you have an angle that's similar, and then or an angle that's congruent, and then a side that's similar, you have the triangles being similar. So if I know that if two sides of one triangle are proportional to the two sides of another triangle, then their included angles are congruent, then the triangles are similar. So this is saying this is given information right here, that x is congruent to angle M. So angle X and angle M are congruent, meaning they have the exact same measurement. And I have to be given another piece of information. I have to know that some things are proportional. I have to know XZ, this line right here, must be proportional to its corresponding side, MP. And that division, that quotient, should be equal to XY over MN. So when I divide this side by this side, the reds by the reds, and the blue by the blue, I should be able to say triangle XYZ is similar to triangle MNP. MNP. So again, you're dividing red by red and blue by blue. If three sides, so the last one is the side-side-side similarity theorem, and if three sides of one triangle are proportional to three sides of another triangle, then the triangles are similar. So this is pretty easy. The idea that if AB So we'll say AB is in blue, and RS is the corresponding side. So we have RS. Then we'll go to red, and we know that BC and ST are similar. So BC over ST. And last but not least, we have the green AC and RT. AC over RT. If we know all those proportions are the same, they all divide and give you the exact same number, we are guaranteed that these triangles are similar. So triangle ABC is similar to RST triangle. Similar. Similar again, meaning not necessarily the same size, but they do have the same shape. All right, determine if the triangles are similar, and then write a similarity statement and explain why that is. So one thing we know about parallel lines that we learned about months ago is that if you have these two parallel lines right here, these ones right here, these in light blue, what we can do is say, well, if we have transversals, we can use the corresponding angles theorem to say that angle C is congruent to angle AED. Those two red angles are the same. And we can say these purple angles, B and ADE, are also congruent. So because we know that, because we now know we have two angles for each of them that are congruent, we can say because of corresponding angles, and angle similarity postulate, triangle ADE is similar to triangle ABC. The small one and the big one are similar. Great. The next thing we're going to say for number 3 is the idea that we have some vertical angles right here. And we also have alternate interior angles, because if we remember, these lines, this one and this one, are parallel, which means this angle and this angle are the same, as well as this angle and this angle being the same. So we actually have all 3 angles, not just 2. So we can say because of alternate interior angles and angle similarity postulate, triangle ACB is similar to triangle ECD. Two triangles are similar. All right, now we can start kind of practicing with the things that we've learned. So the first thing, we're going to determine if these triangles are similar, and then write a similarity statement basically saying the triangles are similar or not. So the first thing we have to do is figure out, hey, are these triangles similar? And there's 3 ways to do it. We learned about angle, we learned about side, angle, side, and last but not least, we learned about side, side, side. 4, there are no sides. There's no way we can figure them out. What we can do, though, is figure out what these last angles are, because if we know triangles, all angles add up to 180 degrees. So you can say, what number would I have to add to 42 plus 58 to get 180? So I could say like 42 plus 58 plus something equals 180. And that something ends up being 80. 80 is this missing side. Oh, that's kind of cool. Because if you see, this one's 80 and this one's 42, this one's 42 and this one's 80, so there's only other one thing that it could be, and that's has to be 58. So because we know all the angles are the same on all these triangles, no triangle ABC is similar to triangle DEF. Again, this is because angle. This one we don't have any angles, but we do have some sides. Actually, we do have one angle, and it's because we know about vertical angles. So we know this and this, these two angles, angle ACB and angle DCE, those are congruent. All right, so now we have to figure out, are we gonna use the sides, or are we gonna use the, which sides we're gonna use? And we have to definitely find a scale factor and make sure that they're the same. So I have to make sure that this and this share a scale factor with this and this. So what I have to say is, okay, I know small and small versus big and big. So I know the small triangle versus the large triangle. So the small one, we have CDE. So 4 over 5 should be equal to 6 over 7.5. And the way you can do that is just you do some cross multiplication to see if it's true or not. 5 times 6 is 30. That's 5 times 6. And then 4 times 7.5, 4 times 7.5 is also 30. And then because their scale factors are the same, right, they share that proportion, then we can say triangle ABC is similar to triangle CDE, and this is because of the side angle side. Next, determine whether these triangles are similar, and if yes, identify the postulate that supports this. So again, I'm going to redraw this so that way these triangles are in the same position. I just think it makes it easier to see. So I know these are isosceles triangles. So this 5 and 5 are on top with the 6 right here. That's X, Y, and Z. And then this triangle over here, in the same position, we have 3, that's the isosceles part, and 5 on the bottom, A and B right here. So we have to determine, is the scale factor the same? So I should be able to say, is 5 over 3 equal to, that's this one right here. Is that equal to 6 over 5? Well, let's look. We can do cross multiplication to see. 6 times 3 ends up being 18, and 5 times 5 ends up being 25. And from what I can tell, those aren't the same. So they are not similar, no. And why are they not similar? They do not share a scale factor. And if yes, nothing, because they're not yes. Couple more problems. We're going to write down the proportion and figure this out. So again, we're just doing proportions here. We know that these angles are the same, this one and this one. But what we have to do is first find the scale factor. And the scale factor, if these were proportional, they're actually given they're proportional, so we have to find the scale factor. We know this side is corresponding to this side right here. so those are corresponding. So then we say 6 over 8 is the scale factor to go from the big one to the small one. So that ends up being 3/4 or 0.75 if you go from big to small. And you can do the reciprocal of that to go from small to big. So I know I have this 10 right here, and I want to find x. So all I have to do is take 10 and multiply it by the scale factor. And I know I'm going from the small triangle to the big triangle because I know 6 is smaller than 8. So I have to multiply it by the factor that's greater than 1, which is the reciprocal of this 3/4, because 3/4 is smaller than 1. So we multiply it by 4/3, and we'll get 40 over 3. That's the number that will go in this exposition right here. And if you wanted the decimal that goes along with that, that's like 13.3 repeating. All right, next one, you have number 8. Number 8 is a pain in the butt sometimes because you have to remember one of the rules. The rule stating that the small triangle right here and this large triangle, we're saying that those are similar. So what you have to say is, okay, find the scale factor. So what you have to do here is say 6x, the small one, this small side right here, divided by this whole big one. So I'm going to redraw that real quick. So this small one combined with this big one, so that's 6x plus 4, because you're combining those sides, should be equal to this small side right here, which is 4x plus 1, over the whole side here. So that's 4x plus 1 plus 3. And I'm going to rewrite that just to make it a little bit simpler to look at. 6x over 6x plus 4 should be equal to 4x plus 1 over 4x plus 4. I just combine the 1 and the 3. Now you will have to cross multiply. And when you do cross multiply, you'll get 6x times 4x, which is 24x squared, and 6x times 4, which is 22x. Then you do 6x times 4x because you're multiplying here now. That's 24x squared. Oh, that's nice. It's the same on both sides. 6x times 1, which is just 6x. And then we have 4x times 4, which is 16x. And 4 times 1, which is just 4. I'm going to write down here. So this is 24x squared plus 22x plus 24x squared plus 22x plus 4. I did mess up real small right here. This is not 22, it's 24. My bad. Okay, thank you for fixing that with me. Cool. I am also going to rewrite this. So you should have 24x squared plus 24x equals 24x squared plus 22x plus 4. What's nice is you can subtract 24x squared on both sides, and that completely cancels these out, which is nice. And I can subtract 22x on both sides, which won't cancel it out completely, but it will make it a lot easier to work with. So we have 24 minus 22 is just 2. And then we just have 4 on this side, so 2x equals 4, and x equals 2. Now that's a harder problem, but we did it. Good job, us. All right, last one. Michael is 6 feet tall and is standing outside next to his younger sister. His shadow is 8 feet long, and his sister's is 5 foot long. How tall is Michael's sister? This shouldn't be too much of a problem. It's just an easy proportion. So we can say that we have Michael up top and Michael's sister on the bottom. Michael is 6 feet tall And his sister is, we don't know. We don't know how tall she is. And we know Michael's shadow is 8 feet long, and his sister's shadow is 5 feet long. You just got to cross multiply 6 times 5 to get 30, and 8 times x to get 8x. And that means x is going to be equal to 3.75 feet. So we know Michael's sister is 3.7 feet tall. Still pretty young, probably not fully grown yet. All right, so this is the triangle proportion, or sorry, triangle similarity, Unit 6, Section 3. Make sure you go over this again. If you have any questions, let me know. And work on your homework, practice it, do the problems on your own. That will really help you get good at all this stuff. All right, make sure to like and subscribe. Have a great day, guys.